Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. A new laser technology is paving the way for tiny biosensors that could potentially move lab testing from hospitals to homes. The platform, developed by a team at Chalmers University of Technology in Sweden, involves surface plasmon resonance, a commonly used tool in label-free biosensing, but only in lab settings, given the expensive and bulky components conventionally required. The new sensor device integrates controlling optics and hundreds of microscopic lasers, all on a 1 centimeter semiconductor chip. More specifically, its surface is a 50 nanometer gold film on glass, with the meta-laser array of VCSELs providing the illumination. This combination excites surface plasmons in the film in what the team describes as a fully planar, miniaturized, scalable, solid-state surface plasmon resonance module. It could even potentially facilitate numerous independent sensing channels on a single chip. The team is now working to boost the device's sensitivity and analysis capabilities. They say the design makes it possible to build portable, battery-powered systems that could be used in nearly any setting. Xscape Photonics, a semiconductor startup focusing on next-generation AI data centers, has announced that its total Series A funding has hit $81 million, after recently receiving an additional $37 million via a new investor, Addition, which joins existing backers like NVIDIA. Company representatives say this latest funding round is helping accelerate their development of multicolor wavelength-division multiplexing fabric solutions, including the recent launch of the Falcon X, the first fully redundant external laser small form factor pluggable device capable of emitting up to 8 wavelengths of light for ultra-fast, high-capacity, low-power optical data transmission. Elsewhere in the startup universe, Femtum, a Canadian spin-off from the Centre of Optics, Photonics and Lasers in Quebec City, has just closed a Series A funding round, led by BDC Capital, totaling $16 million. The company, which develops pulsed fiber laser solutions for semiconductors and photonics manufacturing, says the money will facilitate faster deployment of its short-pulsed fiber laser platform and allow significant expansion of its manufacturing capacity. Infrared thermal imaging cameras are widely used in applications like smart appliances, defense, and security. But their components, namely lenses, are traditionally made of expensive materials and can't be repaired when damaged. Now, researchers in Australia are working on an alternative they say could be a game changer. A team at Flinders University has designed a sulfur-rich polymer that can be molded into a lens. The polymer, which has long been an option theoretically for use in thermal imaging, is made from elemental sulfur, so it's transparent to mid-wave and long-wave infrared light and holds its shape. The team says the sulfur allows the infrared light of interest to pass through the lens, and it also touts a high refractive index, which helps with focusing power. Unlike germanium, silicon, and chalcogenide glass, all used commonly for conventional thermal imaging camera lenses, this new polymer can be mass-produced inexpensively and can even be repaired and recycled. The team is now focused on enhancing their polymer lens to increase infrared transparency. They say it's designed to ultimately support development of ultra-low-cost thermal imaging cameras. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.